way back before 1993, cars used to use Freon in their air conditioning systems. But now the federal government prohibits the manufacture of Freon, and because the supply of Freon is decreasing, the price per pound is increasing exponentially. Right? And here's a function that tells us how much the price per pound is going to be time t, where t is the number of years after 1990. I'll write the formula down here. P of t, now so far here's what this says. The price depends on time, and that is given by, what do we have here, 1.89 and then 1.25 to the t. There's a lot of information here. Let's just read through it before we do any computations and see what we know already. Now, do you see that this is of the form right here? Look at this form right here. This is of the form A naught times B to the KT. Now, A naught, that's that multiplier right here. It's the multiplier of the base. Our multiplier is 1.89, and we know that that's the start value. So you start with that much right at the beginning. Then what have you got here? What is this K? Well, K is the multiplier of T. Now, if I really write this all the way out, which we usually don't do, but wouldn't it be this? 1.25, 1 times T. And that 1, all right, that is really 100%, right, if I made it into a decimal. So what I've got going on here is this. The price of Freon since 1990 at t equals 0, that's 1990, right? T equals 0 is 1990. That's when all of this starts. So at t equals 0, what do you know? The start value is 1.89. So what is this? What is the price? The price is in dollars per pound. So in 1990, the price per pound of Freon was $1.89. And then what's it doing here? What's the growth rate? It's 1, which is 100%. So it's growing at 100% per year. And look at the base. The base is bigger than 1. This exponent is positive, so this is a growth function, right? What we're looking at here is an exponential growth function. And I have an idea what they look like, right? Just a quick sketch curve that I could either draw or just keep in my head because I know what it looks like. Where does it start? It starts here at 1.89. This is the price, there's the origin, and this is time. So what's happening as time goes by? Exponential growth, the price is increasing at an increasing rate. So before I've done any computations at all, just by looking at the formula, I can gather so much information about this relationship between time, the number of years since 1990, and the price per pound of Freon. Now, here's what the problem's asking us, down here at the bottom sentence. Find the price of Freon in 1995 and 1990. Well, we know what it is in 1990, right? It's the start value. So in 1990, what we have here is t equals 0, and the price at 0 is $1.89. So in 1990, let's say the price is $1.89 per pound. Now what about 1995? In 1995, what do you have, t? Well, t, remember, is the number of years since 1990. So we've got 5 years, right? So t is equal to 5. So let's evaluate this. What is p of 5? So we're going to take that 5, put it back into the function, and this is going to be a calculator problem. 1.89 times 1.25 to the 5th. Now what I got here is I'm going to round it off to 2 decimal places because it's money. I'm getting 5.7678, but I'll round off 5.77 dollars per pound. Now there's the last question here, down here at the last sentence. How much did Freon cost in the year 2010? I'll do that up there at the very top right. So in 2010, what do we get for t? Well, t, remember, is the number of years since 1990. So what have we got? This is 20, so t is equal to 20. So what we're going to do is we're going to evaluate a p of 20, And that is going to give us 1.89 times 1.25 raised to the 20th. I'll write that 20 so it's actually readable. Okay, now calculator problem, right? All right, so I got this. Now I'll round off to 2 decimal places. I got 163.93. So let's just summarize quickly. What do we have in 1990? The price of a pound of Freon, right here. 1990 was $1.89. 5 years later, 1995 is up to $5.77. And then what about 20 years later in 2010? Well, in 2010 it's about $164.